Hey everyone. Today we're going to be talking about hacking antivirus programs using the recently discovered AVGater vulnerability. Let's start out with some introductions. My name is Peter Jackson. I'm a senior at Emory University in computer science and in economics, and in a few minutes I'll be joined by Andrew Jones, also a senior in computer science here at Emory. Antivirus has been widely used as a key security measure for end users for quite some time, but more recently antivirus has been warned against by security experts. And even Symantec's VP of Information Security now says antivirus is dead. So if antivirus is dead, what killed it? And do we need to look for alternatives to defend our computers? First, let's take a step back and answer the question, what is antivirus? Originally made to defend from viruses, antivirus now typically describes programs with a suite of features designed to protect from many different types of security threats, not just viruses. So what makes it less effective as a security solution? Well, one of the main issues with antivirus is that it is not effective against new exploits. Protection is primarily limited to known malware, essentially pattern matching to known malware samples with some extra bells and whistles. And it is even theoretically impossible to write an algorithm which can determine whether any arbitrary piece of code is malicious. Therefore, it has to continue to rely on this known malware approach. Sometimes simply recompiling the malware, obfuscating it, or switching up some methods will be enough to evade detection by the antivirus program. So how is antivirus exploitable? Well, to work effectively, antivirus has to take on a behavior similar to malware. These behaviors could be reading through large parts of the disk, sending info back to a server, getting updates and commands from a server, etc. It also has to have a lot of privileges, typically higher than a non-root or non-admin user would have. This makes antivirus a high priority target, and that if a hacker can take control of just the one program, they can have the privileges we mentioned, and therefore take control of most of the computer. Antivirus has already been exploited in a number of ways in the past. One particular instance focused on automatic executable decompression, which permitted remote execution of arbitrary code, and was triggered without user interaction. In another case, the Russian government allegedly used Kaspersky to exfiltrate files. Antivirus regularly sends file samples back to servers, so this seemed legitimate at the time. Let's talk about the AVGater vulnerability. Well, since antivirus has access to protected components of the kernel and also elevated privileges, manipulating the program properly can lead to privilege escalation. The key to this specific vulnerability is the process of restoring files from the quarantine. This vulnerability allows for quarantine files to be restored by the user to arbitrary locations in the file system that the user would otherwise not be able to manipulate. The reason for this is that the process is carried out with higher privileges than the user has. By setting a directory junction, basically a directory that links to a different location, when the antivirus tries to restore the quarantine file to that location, it will restore it to wherever the junction points instead. Let's look at a demo of this specific vulnerability.
We have in this directory here a known malicious DLL that we know the antivirus is going to pick up. So we're going to initiate a scan, and it's going to get found by the antivirus. The antivirus will then offer to quarantine it for us. But before we actually click to quarantine, we're going to replace that file with our own payload, which you can see is much smaller. All it does is essentially execute who am I and store the result in a text file in the public directory. I can show you that there's nothing there now. But what this is going to show us is that our malware is operating at the highest permission level available. Okay, so we're going to replace it with this payload. It's going to get quarantined. Then we're going to delete the original directory and then do essentially, it's very similar to a symlink in Linux. We're basically going to be making a virtual directory junction between X and the antivirus itself. Then when we restore the file, it's going to go looking for its original directory, which doesn't exist, and it's going to put it within its own program files. This is a place that we don't have write permissions. As you can see, we could just try directly copying a DLL into it, but we don't have admin permissions to do that. Now, what does copying version DLL into this directory actually do? Well, what it does is it exploits the fact that there's a consistent search order when looking for DLL dependencies. It first looks in like known DLLs, and then it looks in its own directory. there's usually no version DLL here. So then it goes to the system and like Windows DLL directories, and that's where it is supposed to find the legitimate DLL. But because we've put version.dll in the program folder, it's going to find that first, and it's going to load it as if it's the legitimate DLL. This means that you can take over the program. So essentially, arbitrary write access on a Windows machine can allow you to do a whole lot of nasty stuff, which is what makes this particularly dangerous. Okay, so let's get started. I can show you also the exact, this has already been patched, but here's the exact version of the antivirus needed for this to work. So I'm going to initiate a scan. I'm only going to be scanning the desktop just to make it a little bit quicker. Alright, so we found our malicious DLL. Let me expand this out so you can see it. Okay, so that's the version DLL. It's going to ask us to quarantine it, but before we do that, copy and replace the payload DLL, move and replace. Okay, so now our payload is sitting in X. We're going to quarantine selected. Alright, so it wants us to restart. We're going to restart. Logging in as guest. Alright. X is empty. We're going to delete it. Okay, so now we're going to run this make link command. Alright, a junction has been created. We will open up the malware bytes. So we're going to restore this. Let's go take a look just to confirm that we actually got DLL into, there it is, look at that. So now if we do a restart, which I'll be editing out again, that DLL will actually get loaded up by the antivirus. And there it is. It's got system level authority. So we compromised the antivirus. It's also not starting properly now because it's glitching out because of that malicious DLL. But yep, there you have it.
Alright, so let's talk about a solution to this particular vulnerability. The fix here is to restrict users from restoring quarantine files to locations which they cannot access with their set of privileges. This fix has already been implemented by some antivirus providers, such as Kaspersky and Malwarebytes. If you use these products, it's a good idea, as always, to keep your software up to date so that it will include these fixes. But this vuln is just one of many that has been found in antivirus, so should we even continue to use these products at all? Let's talk about some alternatives. As for consumer product solutions to security, there are a number of companies that provide comprehensive security suites, such as Windows Defender, that can provide a better degree of protection than traditional antivirus. Users should also properly set up firewalls on their devices and networks. And of course, safe behavior is key. Safe browsing, such as disabling flash and recognizing phishing scams, as well as safe device management, like using firewalls as we just mentioned, are critical to preventing malicious software from accessing your computer in the first place.